So today we are talking about angles and angle measures. So I know you guys are familiar with angles. You've been dealing with them quite a bit, I'm sure. You see them all over the place. So basically what we have with an angle, I'm just going to show you here. You have two rays basically that are connected with a common endpoint. And then I can sort of swing this around and I can create angles of all different sizes, but they all have the same basic properties. I have two sides. They are connected here at this common endpoint, which has a special name. We'll talk about that in a minute. And so, yeah, those are angles. So let's go ahead and define them and then talk about how we name them and all that good stuff. So angles are formed by two rays that share a common endpoint. Called the, anybody know? What do you call that point in the corner? Starts with a V.
Vertex?
Yes, vertex. Thank you. Vertex. I'm getting some smaller pieces here. Vertex. Okay, so let me go ahead and draw you one, and then we'll talk about how to name it. So I have some common endpoint, and then you're going to have two rays coming off of that. So that common endpoint right there, we just said that that's going to be called the vertex. And then we usually label that vertex with a letter. So I'll just label it A. And then I also usually have at least one point on each of the other rays. So maybe I have a point B here and I have a point C here. And this sort of space on the interior, this is what we refer to as the angle. Okay, well, I guess the whole thing's the angle, but we can measure this distance in here using degrees, right? So when we talk about a 90-degree angle or a 60-degree angle, et cetera, that's what we're referring to. Okay, so let's talk about naming this thing. And I know it gets frustrating when we have multiple ways to do the same thing, but yeah, and that happens here. We have three ways to name an angle. However, they each have their own merit. So, you know, if there was one way that was the best, then we would only use that one way, right? And the others would just sort of fall by the wayside. But each one of the three, we're going to use them in different situations. So let me explain to you how each of the three works. They're all relatively easy. So here's method one, which is very common, tried and true. If you're not sure, you can always fall back on this one. The problem is that there are simpler ways to do it. So you don't only want to know method one. But here it is. You're going to use three letters where the middle letter, this is crucial, the middle letter is the vertex. The middle letter has to be the vertex. The other two, you're just going to pick one from each ray. And it doesn't even matter in what order you do it. As long as A, in this case, is the middle one. Whoever is the vertex has to be the middle. So, for example, you could call this angle CAB, or you could call it BAC. You can go forwards or backwards as long as A is in the middle. All right? So use 3 letters where the middle letter is the vertex and the other 2 yeah, and the other 2 are points from each ray. So in our example, we can say angle CAB or BAC. You'll also notice that I'm using some notation here, what looks like a greater than symbol, right? That is our symbol for angle. I know it looks like the greater than, like greater than, less than. Yeah, it does kind of look like that. They're not quite the same. I mean, it looks the same when we're handwriting it. When you type it on a computer, they do vary them slightly. Sometimes you'll even see, especially like in books, sometimes they actually put an arc here. So you might see, I'll put it on this one. You might see some people sort of put an arc like that. Either way, so these symbols here are just our symbols for angle. Because nobody wants to write out the word if you don't have to. So you can just use one of those symbols if you prefer. All right, I'm going to show you another example with sort of a diagram that's a little bit more complicated, has a few more angles on it. Let's just say I did this. Q, N, O, P, okay, let's say I had this angle here, or this diagram, I should say, and I wanted to name this angle right here. Can someone give me a way that I could name that angle using these 3 letters? So you're going to use 3 letters. Just make sure that whatever the vertex is your middle letter. And you're using 1 letter from each side. Give it a shot. How can I name this angle? Are we not in a talkative mood today? All right, I got my popsicle sticks. Don't worry. All right, I'll do one way, okay? So then maybe you'll feel more confident. So if I'm going to name this angle, the vertex is N, right? That's the corner. So that has to be the middle letter. So then all I have to do is pick, if this is my angle, right? Take a look. These are the sides of the angle, right? Isn't this how the angle's made up? So what I have to do is I have to pick 1 letter from this side. There's only 1 there, so it's got to be a Q. N has to go in the middle, and then I get to pick 1 of these 2 letters. Doesn't matter which one. So I might name this angle QNM. That's one way to name that angle. Yeah. Oh, I got it. Yeah. In the chat. Yeah. QNM would absolutely work. There's lots of other ways, though. Someone give me another way. I want another way, another appropriate name for that angle besides QNM. Yeah, QNL would work. QNL. There's more. There's at least 2 more. to name that very same angle. Remember that you can go backwards as long as N is still in the middle.
M and Q.
M and Q, perfect. N, M, oh, I'm sorry, M and Q. M, N, Q. And there's one final way, which is?
L and Q.
Yes, L, N, Q. So take a look at all of these. Notice that N is the middle letter in all of them. That has to happen, okay? The only other thing that you're not allowed to do, you can't use 2 points from the same ray. So you couldn't call this like LNM, right? You have to have 1 point from this side and 1 point from this side. So in this case, because Q was the only point on that ray, Q had to be involved somewhere. Okay, but you get to choose whether you're using L or M, it doesn't matter. All right, so that's what we need. If I had said, hey guys, go put a dot on any one of these 4 angles, everybody would have put the dot in the same spot. They would have said, oh, MNQ, MNQ. This is the angle she's talking about. Yes, yes, yes. Okay, so that's method 1, using 3 letters, making sure that the vertex is your middle letter. Okay? Got it. The second method is actually one of my personal favorites, but you can't use it all the time, unfortunately. So here is what's up with method 2. Oh, I never added method 1 of what to name. So method 2 to name, here we go. Method 2, you are simply going to use a number on the interior of an angle. Let me show you what this looks like. I love that this is super convenient when you have a lot of angles in one diagram. Okay, we love using numbers. So let's say I gave you this diagram, right? Oh, it's supposed to be an E, silly goose. All right, so say you have this, right? Let me zoom in a bit. And I want to talk about this angle over here. One thing that I'm allowed to do is I'm allowed to sneak in and just put a number right here. Angle 1, maybe this will be angle 2, angle 3. So what I can now do is, instead of calling this red angle DBC, I could just call it angle 1 if I wanted to. It sort of simplifies everything, and it still is pretty easy. I can see it. Like, yeah, that's always going to be our easiest way. So I know what you're thinking, Mrs. Sapia. Well, why don't we just do that? Get rid of the letters altogether. I'll show you why in just a second. So let's talk about what you could call this red angle. Angle 1, you could still use 3 letters. That's always a choice. So you could call it DBC, or your only other option would be to go the other way, CBD. Any one of those 3 ways would work to name this angle I have highlighted here in red. Okay, let me show you the limitation, though, of using numbers to name angles and why we can't do it all the time, unfortunately. All right, let me show you this diagram. I'm going to zoom in on it here. All right, say I had this scenario. And I wanted to talk about, let's say this angle down here. I could put a 1 here. So there's angle 1, there's angle 2. That's great. That's fine. I can do that. The problem is when I want to talk about the whole angle, this whole big angle here. So hopefully you can see that angle 1 is just sort of this small one at the bottom. Angle 2 is this one up here, but what's this whole big one? It doesn't work to just say, oh, well, it's angle 3 because 1 plus 2 is 3. It's true that the measure of angle 1 plus the measure of angle 2 equals the whole angle. That's true, but the numbers don't work that way. They don't work that way at all. So, because it's a name. It's a name. That's like saying, you know, Susie plus Bobby is Sabi, right? That doesn't work that way. So same idea here. I can't use a number to name this big angle. The only option I have is to name that one using letters. So if I want to talk about that whole big red angle, I'm going to have to say A, B, C. Do you see that? So using numbers for angles is great when it's not subdivided into even smaller angles. It has to represent basically the smallest angle in your diagram, and then you can work your way up. So if it's overlapping more than one angle, you have to use letters. I hope that's clear. All right. So let me just write this in words. That red angle cannot be named using numbers. You must use letters on that one. Okay, so that red angle could be angle ABC, or you can go backwards CBA. All right, so that's really my only downside to using numbers is that I can't, it's not just like a 100% of the time I can just use numbers. It doesn't work like that. Okay, everybody all right so far? I have to turn the page. All right, so I told you that there were 3 methods. So I am going to show you the last one. This one is unfortunately the least common, or the least, I don't know, least reliable. You can use it, you can't use this one as often as the others because for method 3, this is kind of a big deal. And this is where kids get into trouble because I try to use method 3 when they can't. Can only be used if there is no other angle that shares the same vertex. This is a big deal. So if you have, so what I mean by this, if I have an angle like this, the vertex is at B. There's only one angle that has its vertex at B. That's fine. I can use method 3 on this one. Here's the diagram where I couldn't use method 3. I don't know. I'll just do something like this. This second diagram over here on the right, there's a whole bunch of angles that have y as its vertex. So you couldn't get away with this. So what is the method? The method is to just name the angle by the letter of its vertex. Okay, so this one, I could literally call this whole angle, instead of it having to call it angle ABC or CBA, you could just call it angle B. So let's write that out here. This can be called angle B. Just angle B, that's it. Angle B. Because there's only one angle that's attached to a vertex B. With B as the vertex, let's say that. However, on my right-hand side, you could not get away with calling this angle Y, because first of all, what angle are you even talking about? Is it the whole big angle? Is it this small angle here? Is it this small angle here? I don't know. I don't know what you mean. That's why you can't use this method on one like that. So I'm just going to put in here, you can't do that because what angle is it that you're trying to call angle Y? I don't know. There's too many. So, can you get away with naming an angle by its vertex? Sometimes, yes, as long as there's no other angle it could be confused with. That doesn't happen all that often, so we don't rely on that too much. But when I can do it, it does make my life a lot easier. I'd much rather call this angle B than angle ABC, right? It just saves me time. Okay. I think I'm gonna skip that for now. All right. Any question on angles so far? All right, because now I'm gonna sort of transition to the next part, which is measuring angles. Which luckily you guys have been dealing with angles for a long time, so you probably already know a good chunk of this. So let's just get it in our notes, make it official. Measuring angles. I don't know why my pen's deciding to not cooperate all of a sudden. Huh, that's weird. Oh. I got a whole pack of brand new ones. I'll just switch to a new one. Measuring angles. So I already mentioned that angles are going to be measured in units called degrees. So it's just a unit of measurement, just like inches or feet, but we use degrees. And I'm sure you remember that an acute angle does what? Anybody remember? What's the measure have to be on an acute angle? It's more than 0 and less than what?
90 degrees.
Yes, less than 90. Correct. Thank you. By the way, just in case you have forgotten, or maybe you never knew, I don't know. I don't know your life. These little tiny, it looks like an exponent of 0. They're not really exponents at all. That's just the symbol for degree, right? So that little tiny O up high, that's just that symbol. So instead of writing, you know, if it was like 12 inches, I have to write the word inches or use the symbol for inches. Same thing. If I'm doing degrees, I just put the symbol for degrees. Okay, you could write the word degrees, but who wants to do that? Okay, so that little tiny O, just remember that's the symbol for degrees if you forgot. Trying to get this pen, brand new pen, to sort of come alive here. There we go. Oh yeah, there we go. Oh, now we're talking. All right. Much better. Okay, so there's our acute angles. They do have to measure more than 0 degrees. So there are negative angles. We'll talk about that when I see you your senior year for trig. You can go negative. But for our purposes, we're just going to start at greater than 0. If an angle measures 0, it's not really an angle. It's just a ray then. It doesn't have any, right? Because it would just be flat. There's no angle there. So acute is going to be anything greater than 0, less than 90. So of course, your right angle is the one that measures exactly 90. Oh, come on, these pens. I thought this one was going for me now. Measures exactly 90. And then you have, when you go bigger than 90, what are those ones called?
Obtuse.
Yes, obtuse. And then there's 2 more after this. I wonder if you even knew that. So obtuse are going to measure more than 90.
There's more than 100, right? Or 120.
Not 120. You're close though. It's in the 100s. Anybody know? It's more than 90, but less than
180.
Yeah, 180. And then, did you know that we have a name for an angle that does actually measure 180? Anybody know it? Yes, I got in the chat. Straight angle, because it's basically a straight line. So actually, let's rewind for a second. So I have an angle here. If it's 0 degrees, this is what I'm talking about. It's literally just flat, like perfectly flat. That's not really even an angle. It's just 2 rays on top of each other, right? So when you hit 90 degrees, that's when it's that perfect corner, that perfect straight angle, perfect right angle, okay? Makes that nice sharp corner, all right? So anything in here is going to be acute, because these are all in between 0, and 90, right? So all of this is acute. Once you hit exactly 90, that's right. Once you go past it, now we're in obtuse land. So this is obtuse, 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 until it literally reaches 180. Now that's a perfectly straight line, hence why we call this a straight angle. So it's kind of weird because it looks like a line, but you could technically refer to this as an angle, and we name it a straight angle. Okay, so let's add that in. Straight angle measures exactly 180. And then I told you there's one more past this. Anybody happen to know? Because can't I keep going, right? So think about this. I start at 0. Here I am at 0. And then I open the angle up and I have acute, 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 acute. Ding, ding, ding. Now it's right. I keep going. Now I have obtuse, 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 obtuse until I get to a straight angle exactly at 180. But what's to stop me from keeping? I can keep going. I can keep going. Now look, you have this massive angle here. They have a name. Oh my gosh, Lily knows it. Nobody ever knows it. It's called a reflex angle. Yes! How did you know that? Oh, I'm so excited. Reflex. Yes, yes, yes. Good job. Oh my goodness, reflex. So, we're not going to talk too much about reflex angles. I just want you to know that they do exist. So, our focus will mainly be on the first 4. So reflex is an angle measuring greater than 180. More than 180. And then when you take trig with me your senior year, we'll talk more about, because you could literally keep going for a long time, right? So, oh wait, I have it wrong way. So here's at 0, right? I can swing all the way around. Now I'm in reflex, but what happens when you go all the way? If I go past and I keep going, oh my gosh. You can do that. You could have angles that have as big of a measurement as you want, and then we have things that, we'll talk about it in trig. But anyway, let me ask you this question too before we keep going. How many degrees is it in a full circle? If you go all the way around, how many degrees is that? 360, right. So it makes sense that here, look, you went a quarter. Let me zoom out a little bit. That's a quarter of the way around the circle, and a quarter of 360 is 90. So yeah, that makes sense. Another 90 gets you to 180. That's half. You go another 90, that's actually a 270. Right? And then you go another 90, and then that's how I land. So if I do a full circle, you've gone 360 degrees. Right? So it's so cool because you could go like 400 degrees, right? So basically what happens is you do a full circle and then you do 40 more degrees. So cool. Oh my gosh. We'll talk all about in trig. But yeah, important to know, in a full circle, you're going 360 degrees. And we definitely want to make sure that we know at least the first 4. Acute, right, obtuse, and then straight angles measuring that exactly 180. So that one might be new to you, but I'm sure you've heard acute, right, and obtuse before. Okay, and then I just have one little thing left to show you, and then I'll let you guys get the assignment done for today and then have no homework over the weekend, hopefully. So one last thing, I got to turn the page. And let's flip. Okay, so the last little tidbit here is that a point can be on, like literally on an angle. On the interior, or I should say in the interior, of the angle, or in the exterior. Okay, so let me just show you a real quick diagram to show this. Okay, so if I had a diagram like this and I wanted to talk about some of these points. So I have angle B here, and that's the only angle that has B as its vertex, so I am allowed to just call it angle B. So I have point E, for example, is literally on that angle. It's on one of the rays, okay? So I could say this statement, point E is on angle B, right? Now, point A, you can see, is not literally on the angle, but it is sort of like, if you think of the angle as like the Pac-Man mouth, it's about to get eaten. It's on almost, it is on the interior of the angle, because this, if I just shaded in the angle, that would be the entire inside of it, and A is part of that, okay? So point A is on the interior of angle B. That's how we would say that. Interior of angle B. Okay, if those two rays were to come back together, they would squash A. And so naturally you can see that C is on the outside here. It would not get eaten by this Pac-Man mouth. So C, we're going to say, is on the exterior. And I just have one trick question for you, and then we'll be done with the notes. I'll give you a second to finish copying that, and then I'm gonna draw you this picture. All right, you ready for my trick question? Here it is. In this diagram, is point D on the interior or exterior of angle B?
Exterior.
Good guess. It looks like it is, right? But here's why this is a trick question. Remember that an angle is made up of rays, and these rays never end. So they don't literally stop here. See those arrows on the end? So you could make them super long if you wanted. So if I just extend them, right, then you can definitely see that D actually ends up on the interior. So don't be fooled by that, because rays just keep going forever and ever and ever and ever. So D does still count as being on the interior, even though it looks like it's kind of on the exterior at first. Okay, so let's put that in words. Point D is on the interior. Okay, does that make sense? All right, so that's it for the notes today. I do want to explain the homework to you because it's a little bit different. So let me go ahead and pull it up. I think it's live for you already. Oh, no, I'm gonna keep recording because I want to get the explanation of this on there. Oops. What am I doing? I meant stop share, there we go. And let me come on over here. So I can shut this camera off and get it out of my face. All right, so let's share this. Also, just when you log into Delta, you'll still see the test sort of hanging out here, probably. Just because I set the due date to just through the weekend, I think. Or did I do it today? I don't remember. The due date will come up and it'll move away. I just knew that I was going to have people that were absent, and so make sure you scroll down if it's still there, and then just come to right here. We're on homework 13. Sorry, I thought my phone was off, but of course it's not. Homework 13 on angles and angle measures. Okay, so let me sort of walk you through how this works here. The first section, identify angles with terminology. So we're going to click, and I'm going to zoom in a bit. Okay, so it's asking you which angle number represents angle BGD. Let me zoom in even more. And you know what? I think I need my... Get this in here. Okay, so if I'm looking for BGD, I gotta zoom, there we go. So here's how this works. I'm gonna come in and I start at B. So here's B over here, right? So I'm gonna go from B to G, and then I see where D is. Oh, it's down here. So that's the angle they're talking about, this one. Do you see that? So the number that goes with that angle, BGD, is just angle 2. So that's what I'm going to type in the box at the bottom here. You don't have to put symbols or anything, just put the number, I believe. Yeah, okay, great. Let's try another one. Clear this. All right, JRM they want, JRM. So I'm going to start at J, I follow it along, I hit R, and then I see where M is. Oh, it's down here. So I'm going to follow along this way. So let me make this line thicker. That might be helpful. I started J, I hit R, and then I head down towards M. The angle that they're talking about is this arc in between those two. So in this case, it's just angle 3. Okay, I hope that makes sense. So that's that first section. Then what's up next? Identifying angles from 3 points. Okay, now this is different. You ready? Here's what you have to do for these. I think this is super fun. You want to identify angle AFE by clicking and dragging the small yellow dots to shade the angle. So take a look at your diagram here. There's little tiny yellow dots all over it. So what you get to do is you can click on a yellow dot and you can drag it, and look, it'll sort of fan out and create an angle. So I just want to come in. So if it's the wrong one, you just click on it again and it'll go away. Okay. So I wanted angle AFE. So I'm going to come down here. I'm going to start at A. All right. So, and it might be helpful to trace it with your finger too at first. So AFE, I want to start at A, go to F, and I want to end up at E. So that means I want to shade this thingy right here. And just that angle, that's angle AFE. So let me erase this, and I'm going to grab the yellow dots, and I'll just shade from one to the other. There it is. There's angle AFE. shaded in yellow. Isn't that cool? I can't tell you how this little tool is so helpful for me as a geometry teacher to make sure that you know what angle is what. Okay, HGI, I do the same thing. Okay, HGI, I start at H, I'm going to go to G, and then I head towards I. So that means it's this angle I'm trying to shade. Okay, so I'm going to clear this, and then I just grab the 2 yellow dots, swing it around. Yes. Oh my gosh, this is so cool. I'll do one more. AGH. Okay, A to G to H. I see it. A to G to H. It's going to be that angle right there. So let's go ahead and fan it. I love this. Okay, so that's that section. And then the measuring the angles with the protractor part. All right, this is also kind of different, but really cool. So a protractor, I'm sure you remember, is just the tool that measures the degrees. So let's see here. Measure angle KLM with the protractor and write your answer to the nearest degree. So when you scroll down in here, you have an angle. I'm trying to zoom out, but I keep zooming in. Oh, because I'm in this. I want to zoom out further though. Can I? That's in. Oh, I don't think I can go out. So anyway, all you're going to do is you can pick up this protractor by clicking that blue dot and you can move it all around. So to use a protractor, you're just going to put that blue dot on the vertex. So let's come over here. We'll put it on the vertex. And then there's a green dot over here that lets you turn and zoom and do whatever you need to. So all I need to do is line up one of the sides with the 0 degree mark like I have here. And you can clearly see this one is a perfect 90 degrees. So that one wasn't overly hard. I knew that one was going to be 90 already because you could kind of just tell. But anyway, 90 degrees. Let's do another one that's maybe not so easy. Okay, good. So here's another one. First of all, I might ask myself, hey, is this going to be acute or obtuse? I like to start there. It's definitely smaller than 90, so it's going to be some sort of an acute angle. So let me show you how to do this. Again, I'm going to come over here. I'm going to grab my blue dot. The first step is to just line up the blue dot with the yellow dot. Blue dot, bring it over here to the yellow dot. And then you're going to grab that green dot. And this is what lets you can shrink it down, make it bigger, whatever you need to do. And you can just swing it around wherever you need it. So line that green dot up. You need one side of your angle to be on the 0. And then I just followed 10, 20, 30, 40, 50, 60. Looks like I'm at 61, 62, 63. And if you can't see it, you can make it bigger. This is really kind of cool. I have tried this on the tablets and on my phone, and it is definitely doable. It might be a little bit trickier, but you should be able to do it. I think you just zoom in and out with your fingers, and you should be able to move it around. Okay, so 60, 1, 2, 3 is going to be my answer for this one. Let me get down to the bottom, 63. Cool. All right. What else we got? Oh, and then I just ask you straightforward questions. How can you name angle 8? Besides angle 8, which one of these would be appropriate out of your choices here? I'll just pick another random one. Point Q is, and then you're going to tell me if it's on the interior or exterior. Okay, so give this a shot. Does anybody have any questions right now?
I cannot do it at home because it is really annoying to do it on my
Which thing are you trying to do?
The protractor.
Oh, just skip that section then. I was thinking I actually might make that section just, yeah, skip that section. Go on to the next one if it's too annoying.
Thanks.
Yeah. All right.